All right, and now for this third one, we have the D.ii, right? Invested 37,000 Australian dollars in a fixed deposit account with an annual interest rate of 6.4% compounded quarterly. They ask us to calculate for part A the value of D.ii's investment after 2 years. All right, so there's a lot of buzzwords here that can help indicate how you should approach this problem. If you start hearing words like annual interest rate or compounded quarterly or the word compounded in particular, you immediately need to think of compound interest, okay? And in your formula booklet, you're gonna go to it, find compound interest, and work with that. So all of the following parts of this problem use compound interest a lot, so let's get very familiar with it. Compound interest, this is the formula, see? It is asking for five things in order to use it. It asks for FV, future value, PV, present value, N, number of years, K, number of compounding periods per year, and R, the nominal annual rate of interest. Okay, this is a lot of blah blah. Let's go into the intuition of it. Okay, so first of all, your approach for any kind of compound interest problem is first to define those five things. See, so those five things, as we said, was FV, PV, N, K, and R, which we know is in percent. Okay, so in every single one of these exercises, you will be missing one. Okay, I'm going to say that again. You will have 4 out of 5 of these, and the last one is the one that you're going to try to find. All right. So let's first see what we have. Well, they tell us that they invested this amount. So that is going to be my initial value, my present value. Okay. So 37,000 will go right here. They tell us that it has an annual interest rate of 6.4%. So my R is going to be right there. They tell me that it's compounded quarterly. So quarterly in quarts, that means in 1 year I have 4 quarters, right? K is the number of compounding periods per year. I have 4 periods per year because it is in quarters, so K is going to be 4. And N is the number of years they ask us after 2 years. See? So as we can see, our variable, our X, is going to be FV. So as I said, we have 4 out of 5, ¿cierto? The one that we're missing is FV. So what we can do is simply plug in to the formula, which is this one here, okay? And see what happens. So FV stays as FV. PV we said was 37,000. Parentheses 1 plus the R, which was 6.4, divided by 100 times K, which we said was 4. All of this to the power of K times N, which is basically 4 times 2. See? All right. So if you plug all of that in, you're going to end up with just about this number here. And since we are answering to the nearest dollar, we will change this to 42,010 as my answer. See? Now notice, this is worth 3 points. So one of the points is using the formula correctly, another point is followed through, etc. And lastly, do not forget the units, AUD. Okay? So that is for part A. Again, the big idea I want you guys to have in mind is that you will always be missing one. Okay, so you need to identify which one you're missing and work from there. Okay, so that is for part A. For part B, they tell us that after M months, the amount of money in the fixed deposit account has appreciated to more than 50,000 AUD, and to find the minimum value of M, where M is that. So for this next part, we need to identify what we're missing and what we have, ¿cierto? Always keep in mind the 4 out of 5 thing. So now what we're missing is the M months, see? So it's kind of like the time period thing that's going on. We still have it quarterly, so this number does not change. But now we don't know for how many years or also for how many months. So this is now going to be my new variable. We're just going to call it M as they ask for it here. So after M months, that is the variable that we're missing. Or just to be practical, I'm going to put it as X. See, so that is my new X, okay? My future value, right, is going to be a little bit different because now we know that it has appreciated to more than 50,000 AUD, right? And so appreciated means that it increased in value. Depreciated, decreased in value. So my FV is now going to be 50,000. My present value remains the same because it's still the same investment. And everything else stays put. See? So essentially, I still have a 4 to 5, but my values change a little bit. See, so now I'm going to be plugging in FV over here, right? So I'm going to have 50,000 over here, and I'm going to be changing this 2 to a variable. We're just going to put it as X, see? So this is my new out of 5. This is my new 4 out of 5 that I'm working with. This is now the variable that I'm missing, and now I need to find the value of X. Also, small detail, but here it says find the minimum value of M. See? So as the months keep going, my investment, which is basically like this, ¿cierto? Is going to get bigger over time. And so the value of X that I'm trying to find will be in this mode here, ¿cierto? So as long as it passes 50,000, we need to find how many months that is, see? But it can't be less than 50,000. All right, so you write this inequality. That is already a whole point. And now in order to solve this inequality, there's a couple ways to approach it. My favorite is the following. There is the calc and intersect trick. I do have a video on this that goes much more in depth, but basically I'm going to call this y1 on my calculator. I'm going to call this y2 on my calculator. Calc intersect, whatever makes it work, wherever it intersects, is the value of x that I'm trying to find. And so we will approach it that way. So y1, we're going to call it 50,000. And y2 is the whole thing on the right side. See? So I'm going to have 37k times 1 plus fraction 6.4 divided by 100 times 4 close parentheses to the power of 4x. See? So I'm going to go ahead and graph. It's probably not going to show up in my window. That is okay. When this happens, of course, press window. I mean, try to make sure that it can fit into what you're trying to see, right? You have to see the intersection in order to use the function called intersect. You can play around with the window. What I like to do is use zoom, scroll down to 0 and press zoom fit. Zoom fit tends to nail what you're looking for, tends to get the intersection at the very least. So we give this a moment. We can see that there's one of my lines. The 50,000 is probably the one on the bottom. Just to make sure, we're gonna check here. All right, so Y max, we're gonna call it 55,000, and there it should show up. Let me play around with this a little bit more. Apologies. It's probably not gonna be that many months. I'm gonna change my X max, and there's the intersect. See? All right, so that was a little bit time consuming, but I think it's also worth showing that you do have to play around in this part. Okay, you have to play around with the window, play around with its zoom, and make sure that you can actually see the intersect. Once you can see the intersect, it does not have to look pretty, but it has to be able to show up. You press your first curve, it's the one that's 50,000, which is Y1. Second curve, the one that's on the left, enter, and now we have guess. See? Guess is really just to ask your calculator which intersect you actually want. In this case, it's only 2 lines, so it doesn't matter. There's only one intersect. And we get that value there. See? So we get the value of 4.7, give me 1 second, 423, comma 50,000. So what that's telling me is that whatever makes these two equations equal to each other is when x, this guy here, is equal to that. See? So whenever that happens, these two equations are equal to each other. That means that if x is anything greater than this, it will be greater than 50,000. All right, that's the intuition of our approach. And we are not quite there with the answer because it is asking it in months. See, it's asking it for m in months and also m being that. Now, what the hell is that? M being this makes reference to m being a natural number. Okay, so m has to be part of natural numbers. That is kind of how you change this to words. M has to be part of natural numbers. And what are the natural numbers? It's considered 1, 2, 3, 4, 5. So any whole numbers that are positive, okay? Awesome. Now that we're talking about this, might as well cover integers. See, integers is another that's very common. It looks like a z, and that includes the negatives, okay? Negative whole numbers, and also positive, all right? Natural numbers tends to include the zero as well. So I have to give my answer in positive whole numbers. That's basically what it is, and also in months. And so this number right here is in years. See, so 4.7423 years. Well, we're gonna go ahead and take that number, multiply it by 12. Why 12? Because there are 12 months within a single year. And we end up with 56.9. All right. And so because we need to give our answer whole numbers, giving the answer is 56 is not enough, because at 56 I still have not completed this inequality. But at 57, it is beyond 56.9. This is the right amount of months, or the minimum amount of months, better said, in order for this part B to be true. See? So part B is simply going to be 57 months. This is the approach. If you have doubts how you can show your work here, how I wrote it here works perfectly. See, so you define y1, you define y2, you signal that you're going to use calc intersect, you get full credit. I did it in the IB exam, I got full credit. You can trust me on that. See? Awesome. Later on, they tell us that Daisy is saving to purchase a new apartment. The price of the apartment is 200K. And Daisy makes an initial payment of 25% and takes out a loan to pay the rest. See, so she pays part of it, like immediately, and the other part of it, she takes out a loan to pay the rest. So what is the amount of the loan? Well, the amount of the loan depends on how much she paid initially. And so 25%. All right. Quick percentage class. See? So percents, for example, 100%, if you write it as a number or a decimal, it's going to be 1. Okay? That means that 50% is equal to 0.50. Ah, interesting. So 25% is going to be 0.25. Cool. Why is this helpful? It's helpful because now we can take that 0.25, multiply it by 200,000, and find out what is 25% of 200,000. You put this into your calculator, you're going to find that it's 50,000. Awesome. So this is the initial payment, okay? The loan is whatever is left after the initial payment. That it? So if the initial payment is 50K, we're going to do 200K, or 200,000, minus 50,000, and that is going to be the amount that she pays on the loan. The rest, cierto? 150,000. Do not forget the units, AUD. That is the approach for part C, and we move on. So this same loan is for 10 years, the one that is 150,000 AUD. It is compounded monthly, important detail, with equal monthly payments of 1,700 AUD, made by Daisy at the end of each month. So she took out this loan, she got her apartment, she has to pay off the loan, etc. See? So for this loan, we need to find the amount of interest paid by Daisy and the annual interest rate of the loan. So here you have to get a little bit familiar with like the language, like what the hell is even interest in the first place. Point is, the loan she took that she has to pay is 150,000 AUD. See? Now the bank has to make money out of this, ¿cierto? So there's a certain amount of interest that she has to pay, like sort of additionally, in order to, so that the bank makes money, etc. Blah blah. And so simplifying in a lot of ways, we can say that because it's for 10 years, and because it's monthly, so 10 times 12, and because it's 1,700 per month, this minus the loan is the amount of interest that Daisy is going to pay. See? And this difference here, which is going to be a positive difference, ¿cierto? Is the amount that the bank basically gains. That it? Awesome. So if we go ahead and do this, trust me on this, on your calculator, you're going to end up with 54,000 AUD. Okay, I might have gone a little bit fast in this part here. But point is, um, the interest paid, ¿cierto? Is going to be for 10 years, monthly. That's why it's 12, 1,700 per month. And we subtract this of the loan, which is from part C. ¿Vale? That is how the numbers showed up in the first place. That is part D, part I. All right, and now for this next part, we have that for this loan, we need to find the annual interest rate of the loan. Now, a very common mistake here that people do is that they keep working with the compound interest formula. And unfortunately, because we're talking about a loan, we are now talking about an annuity, which is something a little bit different. So basically, whenever you're talking about loans or something with equal monthly payments, this is probably the biggest hint I can give you. You are not going to use the compound interest formula anymore. You're going to use the finance app on your calculator. All right, so this is a big hint for using the finance app on your calculator. If we go ahead and open it, it will be on this apps button that's in purple. We press finance. And there's a lot of things here going on, but you will go to TVM solver. Okay, this is usually the one you're going to always use. And there's a couple things going on. See? So big N is now the amount of compounding periods. And so if before, for example, for monthly, we had that K was 12, and 10 years we had that N was 10, big N, right, which is the one up top over here, big N is now actually going to be a combination of both. Okay, it's the compounding periods, like all the amount of periods, it's going to be 12 times 10. Okay, so big N in this case is going to be 120. All right, so that's with the first one. I percent is the interest rate, which is actually what we're trying to find. Whenever there's something you're trying to find using the finance app, you will leave it on 0. It will make a little bit more sense in a second. For PV present value, right, we are talking about the present value of the loan. And because it's a loan, it actually goes in as negative. So we have negative 150,000, sorry. PMT makes reference to these equal monthly payments, and so we know that each month, or each period better said, it's 1,700. So we're going to go ahead and plug in 1,700 here. FV we will leave at 0, and PYCY makes reference to the compounding periods and compounding years that are going on. In this case, we will leave both as 12. So that being said, we are almost done. What you need to do now is go back up to interest, because it is the one thing that you're missing, right? The one thing that you're trying to find in the first place. And you will go alpha enter. So alpha enter actually gives you the thing called solve. And so the calculator with all the other stuff that you inputted is going to give you the last thing that you're missing. Okay, so the intuition of the 4 out of 5 thing I was talking about earlier is still given here, just that what you're missing is the annual interest rate. And instead of plugging in and using calc intersect, you were plugging into the finance calculator. Again, you press alpha enter, boom, it solves it for you. It gives you that. See? And so within the missing variable, the calculator figures it out for you, and you get, let me just write it down real quick. 6.45779. Same thing as writing 6.46%. How do you show your work? You show your work by writing that N is 120, that PV is this, that PMT is this. You basically write what you put into your calculator. If you want to mega make sure that you're getting full credit, you can even go apps, finance, and write this, and you're going to get full credit. Okay, trust me on that. But anyways, that is part D double I. All right, so for this part E, right, we have that after 5 years of paying off this loan, Daisy decides to pay the remainder in one final payment. Why would he do that? Because it's cheaper, you have to pay less interest, etc. So for part E, we need to find the amount of Daisy's final payment. The approach here is the following. Again, using the finance app thingamajiggy, we need to see what happens, or what is my future value in this case, after 5 years of paying off the loan, right? And so 5 years after paying the loan is how many compounding periods? I'm talking about big N. How many will it be after 5? Well, if after 10 it's 120, I can just take 120 divided by 2, and that will be after 5 years. See? So that's one approach for figuring out what big N is. The other approach is saying, okay, well, 5 years, and we have that it's monthly, right? So 5 times 12, that also gives you 60. See? So two ways of getting the same answer. Whatever. Point is, you put 60 up here. Everything else is already plugged in. And now we will find what my future value is. See, so I'm going to go alpha, enter, get that solve, and we end up with that. So the amount of Daisy's final payment has to be 86,973 AUD. Awesome. So this is how much she still has to pay for the final payment. See? Nice. For part F, we need to find out how much money Daisy saved by making one final payment after 5 years. And so the first thing we have to figure out is see how much Daisy has to pay in interest in total and compare that to her paying everything right now immediately. So here we have to go a little bit back in time. If we see here for part D, part I, we have the amount of interest paid by Daisy. Back then, we figured out the amount of interest paid by Daisy was 54,000. Okay? And the loan was, as we can see over here, 25%. The amount of the loan was 150,000. Stay with me for a second, it's all going to come together. So, the amount of the loan was 150,000. The interest she has to pay was 54,000. That means that in total she had to pay 150k plus 54k in interest. She had to pay 204k. See? So this is the amount she has to pay in total. But because she paid earlier, she actually saved some money. So how much money did she save? Let's find out. We subtract this number to the following amount. We first put this guy here, ¿cierto? Because it's what she paid. She already paid after 5 years. So we're going to be subtracting by 86,973. And we also subtracted by the next 5 years. See, and so the next 5 years, how much would it be? It would be 60. Why 60? Because of the 60 over here. Times 1,700. Why 1,700? Because she pays 1,700 per month. So that being said, you go ahead and calculate that. You end up with 15,027 AUD. I think the hard part here is noticing that you need to find out this number, 204,000. And understanding that you have to subtract both things over here. See, not just one of them, it has to be both. So that is for number 3.